one and all. In today's lecture, we will start the last unit of our syllabus. This is given on application based combined loading and stresses. What is the application of the combined based loading and stresses? Already we have seen the 5 units. We have seen the different types of the loading. Tensile load is there, compressive load is there, shear stress is load is there, flexural load is there, bending load is there. Okay, different types of the loading we have seen already. Okay, this unit is totally depend on that unit 1 to 5. Whatever may be you have studied in the unit number 1 to unit number 5, this is depend on the unit number 6. First, tell me what is meant by direct stress. We have seen there is if you have given the eccentric loading on a beam, okay, or we can say the column, there is a subjected to the both direct stresses and bending stresses are induced. In this unit we will study and you think we will find out it is the combination of the bending stresses and direct stress. Okay, and also we will see the eccentric loading. Okay, first you know the direct stress. Yes, anybody? Direct stress is denoted by the sigma is there. Okay, sigma d. The load which is induced the centroidal of the axis of the column is known as a direct stress. It is denoted by the sigma suffix d. Okay, direct stress, the load which is induced centroidal of the axis of the column is known as a direct stress. It is sigma d is equal to, again we can write the force applied on that centroidal axis P divided by cross sectional area A. Okay, very simple. It is denoted by the sigma d. All of you getting? Then say next is a eccentric loading is given. Eccentric loading. I have considered for the direct stress here maybe, as well as I have taken the front view of this. If you have checked the axis of the column, okay, there is a force P is applied on that axis. See here is also force P is applied. Okay, this is known as a direct stress. What is the eccentric loading? What is the eccentric loading? The load pulls the line of action. Check that. The load pulls the line of action does not coincide with the axis of the column. Does not coincide with the axis of the column. This type of load is called as a eccentric loading. It is denoted by the small e. Okay, if you want to calculate the eccentricity, then how to calculate? It is the distance from the centroidal axis to the force P is at on the given column. This is known as a eccentric loading. Okay, they are not coincide with the axis of the column. Okay, here we will get sometimes here, sometimes here. This distance from the centroidal axis to the force P is at. This is known as a eccentric loading. Okay, both concepts are clear. What is the direct loading and what is the eccentric loading? Next is a combined and direct bending stresses. Okay, combined and direct bending stresses. What is the combined and direct bending stresses? When the member is subjected to the direct and bending stresses, then the resultant stress will get the combined direct and bending stresses. Okay, when the member is subjected to the eccentric load, okay, P is there, eccentric load, we have seen the eccentric load definition, is induced, then both direct and bending stresses. Okay, this resultant stress is called as a combined direct and bending stress. If there is a eccentric loading is there, then you will get the combined direct and bending stresses. Where is the application of that combined and direct bending stresses? We have seen the different types of the dams, chimney is there. Okay, when the water is flow on the earth, okay, then again wind pressure is there, wind moving on the earth, then we get the bending stresses in the column. Okay, because due to the wind pressure, this column will be bent. Column will be bent. That's why we get the bending stresses. Okay, when we apply the some load, there is a direct stresses are induced. But due to the water, earth, and wind pressure, there will get the bending stresses. Then how to calculate that combined direct and bending stresses? You know the combined stresses are denoted by the capital sigma. Sigma is there. Okay, it is the summation of direct stresses as well as bending stresses. Sigma D is denoted by the direct stresses. Here is the direct load is at P, and what is the area? Area cross section, it is denoted by the A. Here is the plus or minus because of maximum and minimum stresses you can calculate. That plus, how to calculate the bending stresses? In the unit number 3 we have seen it sigma B is equal to M by Z. What is the M? Yes, anybody? What is the M? M is nothing but the moment about that axis. Moment about that axis. Moment is again, what is the moment? Moment is a force into distance. We have seen the unit number 2. What is the moment? Moment is a force into distance. Force again denoted by the P, and what is the E? E is the eccentricity. Okay, from the centroidal axis to the where is the force is at. What is the Z? Z is the sectional modulus. Z is the sectional modulus. Again, what? How to define that Z? Z is equal to what? I by Y is there. I, what is the I? Moment of inertia. What is the Y? Y is the maximum distance from the centroidal to the base or top. Okay, all these things we have seen in the unit number 3. Okay, and this direct stress we have seen the unit number 1. This is the combined direct and bending stresses. Then how to calculate the maximum stress? Sigma max is equal to P by A plus M by Z. This nature of the stress, you will get the compressive maximum stress. And what is the minimum stress? You will get the nature P by A minus M by Z. The nature of the stress is a tensile. The nature of the stress is a tensile. Then next thing is a, all of you getting this combined direct and bending stresses? There is a eccentricity. Okay, this, then there is a load is induced direct and bending stresses. Okay, and you will get the resultant stress is a combined direct and bending stresses. Very simple. Then third is a condition for the stress distribution at the base. Okay, condition for the stress distribution at the base. Okay, see here I have considered the one column. I have taken the cross section of that column, and here is a load is at P load. Okay, then we will get the eccentricity E from the axis of the column to the where is the load is at P. This horizontal distance is a E is there. Okay, then see the first condition. First condition is a if the direct stress is greater than the bending stress, then what happens? If the direct stress is greater than bending stress, then is a stress distribution is totally compressive. Okay, remember that, and you will get this shape, this column, this type of stresses is that. Okay, sigma minimum to sigma maximum. Okay, if the sigma D direct stresses is greater than bending stresses, then there is a, we will get the shear distribution is a total compressive. Then second condition, if direct stresses is equal to the bending stresses. Then what happen? You will get the minimum stress is a 0. Minimum stress is a 0 in this condition. Sigma D is equal to sigma B, and you will get the stress distribution is again totally compressive. See, then you will get this sigma minimum is equal to 0, and here you will get the sigma max. Sigma max. In this 0, then total you will get the slowly this the stress will be increases, and here you will get the sigma maximum value. And last condition is a direct stress is less than the bending stress. Then what happen? Direct stress is less than the bending stress. Then you will get the stress distribution is partly tension and partly compression. Partly tension and partly compression. And what is this? You will get, we have seen in the third unit. Okay. Sometimes about that axis, if you have looked at this diagram, then you will understand. Okay. In this way, we have seen the stress distribution diagram or stress distribution diagram. Right. Above that neutral axis and below the neutral axis, here you will get the tension, sometimes here you will get the compression. Right, we have already seen that in unit number 3. You should remember that 3 conditions. You should remember that 3 conditions. Then after that, we will see the eccentricity is there. Eccentricity. Okay, I have explained already. Eccentricity is nothing but the horizontal distance between the line of action of the force to the centroidal axis. Okay, horizontal distance between the line of action of the force from the centroidal axis is nothing but the eccentricity. Okay, then they have given the condition for the no tension. We'll see the condition for the no tension. Yes, all of you getting up to this? Yes, good. This is the important, okay, condition for the no tension. Next bit is a condition for no tension. If we want to find out the no tension zone, okay, there is no any force is applied. Okay. We have seen when there is a eccentricity is induced, applied on the given column, then there are both stresses are induced, direct stress as well as a bending stress. Okay, then resultant stress at the base may be produced tensile or compressive. Resultant stress at the base of the column may be produced compressive or tension. Compressive or tension. Okay, tensile stress at the base of the column is harmful as it produces the tensile force. As it produces the tensile. Okay, if there is a column, sometimes you will get the tension or compression, but at the base of the column, if you are getting the tensile stress, it is a harmful to produce the tensile crack. Okay, here you will get the some tensile crack of the column at the base. Then we want to avoid this tensile crack. Then how to avoid that tensile crack? To avoid this tensile crack for the no tension condition. Condition for the no tension. Then what is this condition? This direct stress is always greater than or equal to bending stress. This is the no tension condition. Okay, you should remember that condition. This is very important. This direct stress is always greater than or equal to bending stress. Then we know that what is the direct stress? We have seen here sigma D is equal to P by A is greater than or equal to what is the sigma B? M by Z is there. M by Z is there. Again we will put here P by A is equal to greater than or equal to M means what? P into A divided by Z is there. P into A divided by Z is there. Okay, again this P get cancelled, P get cancelled, and you will get the 1 by A. 1 by A is greater than or equal to E by J. We want to calculate the eccentricity for this column to avoid the tensile crack at the base of the column. Then we can write E is less than or equal to Z by A. Okay, you should remember that formula. This is very important formula. When you calculate for the different section, if you have given the rectangular section, rectangular hollow section, then circular section or circular hollow section, then you have to calculate the eccentricity for this. Okay, then general formula is eccentricity is always less than or equal to Z by A. You should remember this condition for the notation. Okay, is less than or equal to Z by A is there. Z by A is there. Then next we will see the core or kernel of section. Next heading, core or kernel of section, or it is also called as a middle third rule. Core or kernel section. It is very important. When you are solving the numerical, then we know that the core or kernel section. What is the core and kernel section? We will see the details one by one. Core or kernel section. The central portion of the cross-sectional area with the, you have given the which a direct stress, okay, or we can say the direct load to so that there, if there is a central portion of the cross-sectional area, suppose this I will draw here for the rectangular section. I will explain. First I will take the rectangular section with the help of that rectangular section. Here is a 2 dimensions are given. One is a B, width and depth of the rectangular section is a D. Okay, these 2 dimensions are given. Okay, we have calculate this. I will divide it into mode D by 3. Again here D by 3, and from this to this remaining distance is a D by 3 is there. Similar way for the base, this distance is a D by 3. Then this one is again D by 3. The remaining distance is a D by 3. Okay, we have considered the central portion of the cross-section area within which, check that, the central portion of the cross-sectional area within which the load is at on that cross-section, then we can say there is a no tension will be produced in the zone of the cross-section. In the zone of the cross-section, or we can say that part of the cross-section is called as a core or kernel section. Okay, see, we want to calculate here eccentricity for the rectangular section. Okay, if direct load is at in the cross-section of the area of the cross-section, then there is a, we can say this is the no tension zone. No tension zone. If the load is at here, then we want to calculate the eccentricity for this. Okay. Then what we want to calculate the eccentricity for the rectangular section. Okay. We have seen E is less than or equal to Z by A. With the help of that, you have to calculate the eccentricity for the rectangular section. What is the area of that this rectangular? Yes, anybody? Area is equal to what? B into D is there. B into D is there. What is the Z? Z is equal to I by Y is there. I by Y is there. But we want to calculate the eccentricity for both. Here you have to calculate the Ix and Iyy value. Okay. What is the Ix moment of say about the XX section? That section. You know that BD cube divided by 12 is there. And what is the Y? Y is the D by 2. D by 2 is there. I have calculated directly ZXX. And what is the ZYY? Is then DB cube divided by 12 divided by B by 2 is there. B by 2 is there. Okay. Put this value in that equation. Put this value in that equation. You will get this ZXX. Check that. First I will put this ZXX. Check that. E is less than or equal to ZXX what? BD cube divided by 12 divided by D by 2 is there. Okay. Again divided by what? Divided by what? Area B into D. B into D is there. You will get this E is less than or equal to E is less than or equal to D by 6. Sorry, I will check that. D by 6 is less than or equal to D by 6 is there. B by 6 is there. You can choose the XX value only. Section B by 6. Okay, this is the eccentricity of the rectangular part. B by eccentricity is less than or equal to B by 6 is there. Okay. Then you can calculate again, convert this. I will convert 2E is equal to B by 3 is there. Less than or equal to. Okay. This is the formula for the rectangular section. And similar way, if you have calculate for the ZYY, if you are putting here ZYY divided by A, then you will get the 2E is less than or equal to D by 3 is there. D by 3 is there. Okay, all of you getting how to calculate that? D by 3. Yes, eccentricity with the help of that condition for the no tension zone. We want to find out the first no tension zone. How to calculate? This direct stress is always greater than the bending stress. Bending stress. That we have to find out in this rectangular section. Use this formula Z by A. Z by A. If there is a direct loading is given on the cross section of the area of the cross section of the beam, then there is a no tension zone is there. No tension zone is there. That resultant is given the overall corner section. It is also called as a middle third rule. Middle third rule. Remember that. This is the middle third rule is there. Okay, today we will stop. Next lecture we will see the hollow rectangular section. Then again circular section and hollow circular section. What is the eccentricity for all? Okay, today lecture will stop here.